Yeah,
exam on Tuesday. Dr.
I didn't hear it. What?
Dr. Bilal said that on Tuesday the exam will be not on Monday because on Monday there's conflict between some students' exam.
Okay, okay. And let me make sure of that. If that's the case, then forget what I said. We'll just do it Monday as usual. Okay.
Okay.
I'll make sure of that. So if you do have an exam on Monday, it'll be like this, but since probably you don't, we'll just do it as usual Monday at 5 p.m.
Doctor, is it Moodle based?
What's Moodle based? The exam? I have no idea. You have to ask Professor Saad.
Thank you.
Welcome. Okay. So let's start with proofs. These are some of the tools ideas we've ran over through far. So we have inference rules where we have a bunch of premises and we want to reach a conclusion. We have direct proof where you just literally go through the proof and do it. Contraposition, contradiction, and counterexample. Counterexample is usually when you want to disprove something. So let's start with this. Check whether the following statement is true or not. If x, y belong to z, then and x, y are odd, then their multiplication is also odd. So here we're going to be doing a direct proof where we just try to do that. So step one, let x equals this and y this. Now, if an integer is odd, then it's going to be of the form 2k plus 1. If it's even, it's going to be just like 2k. So like a multiple of 2. Here we're saying it's the remainder is 1 after dividing by 2. Now the reason why we say m and n, because they're not necessarily the same. If you both use the same variable for x and y, like m and m, it's like saying x equals y, which isn't necessarily the case. Okay, so we defined our x and y, and we assumed they're odd. So now let's see what their multiplication will be. And it'll be something like this. So if you just expand it, so you get 2m times 2n plus 2m, and so on. You do simple expansion, then you take 2 in common, all of these will be inside the brackets, and you're left with a 1. And since m and n, they both belong to the integers, then their multiplication belongs to the integers, and the sum of them will be also in integers. That's why this is odd, because you multiplied them and you were able to reach the format that we know for odd. So all of this can be some variable s that belongs to z. Hence q is true. Any problem with that? This is a direct proof. Okay, moving on. So this is one way of doing it. Another way might be using contrapositive or contraposition. So we have our original statement is P implies Q. The contrapositive says, hey, let's try to prove not Q implies not P, because they both have the same truth value. So if you're able to prove the contrapositive, you just proved the original statement as well. Now, our original statement was this. If x and y are odd, then the multiplication is odd. Contrapositive says this. If the multiplication is not odd, then x and y are not odd. What does it mean that the multiplication is not odd? It's just even. What does it mean that both x and y are not odd? It means that one of them is even. So you can either prove the first statement, which we just did, or you can try to prove the second one. you'd like to use the contrapositive if you feel the original statement was too hard. Like here, I feel like they're the same difficulty. But this is just an idea. If you're trying to prove the original statement and you're not going anywhere, maybe try the contrapositive. Is this an exclusive or exclusive or, by the way? So like, is it XOR or the normal or? If I say, okay, so that's. Do you mean, Zahra, do you mean the normal or the exclusive one? Like if I say X or Y is even, does that mean only one of them can be even or they both can be even? They both can be, yeah. Both of them can be even, which is why it's inclusive. It would have been exclusive if, hey, X can be even but not Y, or vice versa. But hey, it's fine. When you multiply two evens, they're gonna be even. Good. Moving on. Show that if m squared is a multiple of 3, then m is also a multiple of 3, such that m is an integer. When I say m belongs to z is the set of integers. So it's, imagine like you have a 0 in the middle, then 1, 2, 3, you keep going forever, then -1, -2, keep going forever in the opposite direction. So it's all integers. Show that if m squared is a multiple of 3, then so is m. Well, we could try to use, let's say, contradiction here. Yeah, why not? So they're telling you this is your given. M squared being a multiple of 3 is given. It's something that's true. We have to prove that m is also a multiple of 3. Well, if we assume that m is not a multiple of 3, and we reach some sort of contradiction with our given, then we solved it. So we assume that m is not a multiple of 3, and at the end, hopefully we'll reach that, hey, m squared is also not a multiple of 3. But that's a contradiction since it's given. It's given that it is a multiple of 3. Like, it's your rule, it's your axiom. So if you reach somewhere that m squared is not a multiple of 3, then that means your assumption is wrong. And since our assumption was that m is not a multiple of 3, that could only mean that, yes, it is a multiple of 3. Okay. But what does it mean to be a multiple of 3? Or not a multiple of 3? Well, before we said if something is even, it's going to be 2k. If something is odd, it's going to be 2k plus 1. Like your divisor, the thing you're dividing by, which is 2. So it's either a multiple of 2, or after you try to divide by 2, you get a remainder of 1. Same thing for a multiple of 3. So either you're going to be a multiple of 3, so 3 times k, or after dividing by 3, you get a remainder of 1, or after dividing by 3, you get a remainder of 2. You can't get a remainder of 3 because, hey, 3k plus 3, you take 3 in common into k plus 1, it's back to a. It's back to being a multiple of 3. So yeah, if something is either divisible or not divisible by 3, you get 3 possibilities. When we go with divisible by 4, you get 4 possibilities, 4k, or +1, +2, +3. Oh, okay. Since we're assuming that m is not a multiple of 3, then m can either be 3k +1, or m can be 3k +2. It's either this or this. If it was the third case, then we're done. Hey, it's a multiple of 3. Well, what happens if m equals 3k +1? Let's check what happens with m squared. It's gonna be 3k +1 squared. So if you expand it, 9k squared plus 6k plus 1, right? Okay. Well, if you take now 3 in common, 3k squared plus 2k plus 1. Remember, this is m squared we're talking about. So again, since k belongs to z, then the multiplication, the sum, it's all also going to be in z. So we reached that m squared is of the format, let's say 3s plus 1, such that s equals this thing. But there's a plus 1. So we're saying here, no, m squared is not a multiple of 3, because, hey, there's a remainder 1. So, contradiction. We assumed that m is not a multiple of 3, and we got that m squared is also not a multiple of 3, which contradicts with our given. Like the first part of your implication, you have to assume it's law, it's true. M squared being a multiple of 3. So there's your contradiction. But that's not over yet, since you only did it for this case. You also have to do it for this case as well, but it's the same thing. Simple expansion, you take 3 in common, you'll get that it's a multiple of 3. Does anybody have a problem with this? Okay. So we did it with contradiction. In the solution, they're talking cases, but it's pretty much the same. Like they're saying, hey, m is either a multiple of 3 or it's not a multiple of 3. So another way of proofs is using cases. So if you say, hey, m is a multiple of 3, then you're done. You're trying to prove that m is a multiple of 3. So if in your first case m is a multiple of 3, just you're done right away. Second case is m is not a multiple of 3. So like we said, it's either the remainder is 1 or the remainder is 2. If it was the first case, they reached that it is not a multiple of 3. Same thing for the second case. So they did use cases, but it's kind of like contradiction, because they reached, hey, therefore m squared is not a multiple of 3. So whatever you're comfortable with. Okay. Moving on. Try to do this. Prove that if n is a multiple of 3, then n squared is also a multiple of 3. If you have questions or anything, let me know. Otherwise, take a minute or two to do this. Okay, a little bit too much time, maybe. So if you noticed, it's the same way as going backwards from what we just proved. So before here, we were saying, hey, m squared multiple of 3, then that means m is a multiple of 3. Here, it's like going the other way. N is a multiple of 3. Then n squared is a multiple of 3. But it's like if you, here we're saying n and there we're saying m, but it's just a variable name. So it could be the same thing. You could just say n. So it's kind of like we're saying there's an equivalence here. If you have one, then you have the other. If n, only if. So easy enough, suppose that n is a multiple of 3. Then n is 3k. There's no remainder here. There's no +1 or +2. It is a multiple of 3, so just 3k. For some integer k, it's important that you specify that k is an integer because it could belong to other things. N squared is just going to be 9k squared. You take 3 common, and there you go. Okay, so 3k squared, it can be an integer, Therefore, yeah, it is a multiple of 3. Any problem here? Okay. If there's a problem, stop me. Now, prove that if n is not a multiple of 3, then the remainder when dividing n squared by 3 is always 1. So if n is not a multiple of 3, what does that mean? N is either 3k plus 1 or it's 3k plus 2. I use k because that's usually what we use, but you could use other names for it. Then the remainder when dividing n squared by 3 is always 1. Hint, use proof by cases, so this case and this case. What do you think is going to happen? So ideally, like you'd assume, for example, n is this. You square it. You want to get somewhere which is like this. 3 something, for example, plus 1. So remainder is 1. Is it obvious that this is what's going to happen? Like, should this happen? Well, you could just solve it and see what happens. But it's again similar to what we did in the previous exercise. When we were trying to solve by contradiction, and we assumed that m is not a multiple of 3, we reached that m squared has a remainder of 1 in the first case, and again a remainder of 1 in the second case, this thing. So yeah, if you notice that similarity, then great. Otherwise, it's still fine. You just solve it and you get there. So far, this isn't very hard. Okay. So case 1, let me just get, this is saying that when you divide by 3n, you're going to get a remainder of 1. Okay. So n modulo 3, so the remainder of division after 3 is going to be 1. So this is just saying n is 3k plus 1. Second case, the remainder of division is going to be 2 after you divide by 3. Okay. Now this thing. It's similar to a question you have in your assignment. Prove the following statements are equivalent. So you have a bunch of statements we want to prove that they're equivalent. There's two ways to do it. You can either say, hey, 1 implies 2, 2 implies 3, and 3 implies 1. So like you're doing kind of a circle. So like they're all equivalent. They all imply each other. Or you can do something like their hint, because usually this might make things hard. In your assignment, I think this is the way to go. So you might, in your assignment, you might have 4 statements, I believe. So you just say 1 gives me 2, 2 gives me 3, 3 gives me 4, and 4 takes me back to 1. But here, let's try something different. Let's try to prove the following. First, we'll do 1 implies 2, then 2 implies 1. So kind of proving that 1 is equivalent to 2. Then with 3 and 4, we're proving that 1 is equivalent to 3. But since 1 is equivalent to 2, then that's equivalent to, then 3 is equivalent to 2, and like you're done. Both ways work, but let's go with the hint, because usually if you're given a hint, that means either another way is harder or this is like the fastest way. So try to do 1 and 2. We'll see what happens. Ask me if you have any problem. Was anybody able to finish the first one, part A? Part 1? Okay, I'll try to give you a hint. I'll do the first one. Usually when you remember, this is an implication. So you're given 1 as given, and you want to reach 2. So in order to make use of your given, here you have to try to find it in 3n plus 2. So we want to prove that 3n plus 2 is even. In order, again, to make use of my given, I have to find the n minus 5 somewhere here. Well, I have n here. What would happen if suddenly in its place I had n minus 5? Well, that would be great because I then can make use of my given. But in order to have this here, I have to add 15. So like you add 15 and you subtract 15. So kind of like you're adding 0, so you're doing nothing. But now I can take 3 common between 3n and minus 15. So I get 3 into n minus 5. Okay, good. Then what? Add the positives together, so that's plus 17. Now you make use of your given, which is n minus 5 is odd. So substituted by the formula of odd, which is 2k plus 1 plus 17 again. Let's expand. I have 6k plus 3 plus 17, which is 20. It's important to always remember your goal, which is you're trying to prove that this is even. So you want it of the form 2 times something. Well, since you have 6 times k and you have 20 here, it's pretty easy to do. Just take 2 common. You're left with 3k plus 10. Assume this is something that's an integer. So 2r, for example, and you're done. You just proved that 1 implies 2. Was that hard, this part? So kind of a direct proof here, you could say. Can anybody give me an idea of how to do 2 implies 1? Or I'll give you a hint, because I feel like the direct proof in this case is going to be harder. So this is 1 implies 2. We now want to do 2 implies 1. So you start off with 3n plus 2. Here it's kind of harder to reach the form of n minus 5. When I first tried to solve this, I thought, hey, maybe I can do, we know that 3n plus 2 is even, right? So it equals 2k. So I thought maybe I could work that equation and try to reach n minus 5 on the left side and reach 2k plus 1 or something, 2 times something plus 1 on the right. So when I did that, hey, step 1 would be subtract a lot. Like to take 3 common, you need 15, so you can get minus 5. So subtract a lot, like 17 on each side. So 3n minus 15 equals 2k minus 15. Then I took 3 common and minus 5 equals, this is actually, sorry, 17. 2k minus 17. And then I was stuck here because I couldn't know how to move further. Like I can't divide 3 because the right side doesn't show me that it's divisible by 3. So that's how I got stuck. Like here, going through the direct proof didn't work for me. So then I thought maybe I can try to do with what I did with the first implication, but in reverse. Like I start here and go backwards. But to do that, I have to use contradiction. because here in the proof, if I want to go backwards, I have to substitute n minus 5 by odd. But I can't do that if I'm trying to prove that it's odd. So instead, hey, just like before, we have 2 implies 1. 2 is your given. Assume that 1 is wrong. So assume that n minus 5 is even. And let's reach a contradiction. So this is first try. It's fine if you don't get it from your first try. I didn't either. Second try, contradiction. Or trying to find contradiction. Don't just start contradiction right away. So assume n minus 5 is even. Okay. Again. So now 3n plus 2. Same as before, we're going to try to find n minus 5 in it. So it's 3n minus 5 plus 17. But now, since I assumed that n minus 5 is even, I'll substitute it with something that's even. So 3 into 2k. Expanding. I'll get 6k plus 17. Just add and subtract 1 as well. Because, you know, you want to take 6 in common here, let's say. Or what do we want to take in common? Let's say 2. What happens if we take? No, it's, okay, forget. Let's take 6 in common. So you get k plus 3, right? Like you have 3 6s in an 18. And then you subtract a 1 here. Do you get like the idea of what's happening here? Just add a 1 and subtract a 1. Then you take 6 in common, like to remove all of it. And if you take, and 6 is just 2 times 3, right? So it's like 2 into 3 into k plus 3 minus 1. And that's another form of odd. When you reach 2 times something minus 1, it's kind of like 2 times something plus 1. It's of the odd form. Does that make sense? Any problem here? Again, so my train of thought here was usually you try to go with the direct proof first. We tried it, we got stuck, we tried a different approach. First thing I thought was contradiction because I'd like to use the opposite of what happened in the first implication. You might have tried contraposition or something like that. That's also fine. Actually, here would be a pretty nice place to try the contraposition idea. Okay. I'll leave you with 3 and 4 because I want you to try to solve this on your own. And if you have problems with it, you can let me know. Okay, use the forum and I'll answer you. Let me see if I can give you a hint on one of them. Yeah, for 1 implies 3, try to do the idea we did with here. Like try to find n minus 5 in n squared minus 1. So n squared minus 1 is just n minus 1 into n plus 1. So try to find n minus 5 here and here. I literally just gave you the solution, but that's okay. I won't say anything about part 4. I'll let you handle it. Okay? If you feel you're not being able to think of this on your own, step 1, try to understand what I'm saying. Then step 2, work on it on your own, and That's how you'll build that critical thinking. But in the meantime, let's go with some more proofs. I really need you to work with me here, okay? We're gonna do this problem together. So try to take a deep breath. Let's energize. Consider this formula. For every x, for every y, there exists a z such that z is greater than x and z is less than y. For which universes, like domains if you want, but not the domain you've been used to, ranged of quantified variables x, y, z, is this formula valid? Explain your answer. Like we're saying, for these ranges, like so the natural numbers is just n. It's 0, 1, 2, 3, so on. Integers, we've seen it. Quotients, it's just the fractions, so it's q, any fraction x over y. Of course, y can't be 0. And then you have the real numbers, r, which is kind of like integers, but you get all the decimals as well, and some rationals, irrationals. So think of it as pretty much anything. So given these ranges, we want to find out for which formula, which of these have the formula value. So can anybody tell me what's the formula trying to say? Like when you say I can find a z that's greater than x and less than y, what's that kind of telling me? So if this is your n, and you choose any x and any y, are you able to find something in the middle between them? So that's kind of what your first intuition should be, right? Hey, you got an x, you got an y, can you find something in the middle between them for any x, y? So would it work for the natural numbers? Would this formula be true? You guys aren't gonna make me do a poll, are you? Whoop. So what do you think? For the natural numbers, would this work? Well, for example, if x is 3 and y is 4, this wouldn't work because you can't find something in the middle. Remember, it's strictly greater than and strictly less than. So can you find something that's strictly greater than 3 and strictly less than 4 that belongs to the natural numbers? Like, can you find 3 point something that's between these two? No. So it doesn't work for the integers because, hey, this is a counterexample. What about the integers? Would it work for them? So Samer's saying no. Can you give me a counterexample of why it wouldn't work for the integers? Okay, I'm seeing 2 no's. Great, but can you give me a counterexample, like why it wouldn't work? Like how I did it for the natural numbers, I said 3 and 4. Why wouldn't it work for the integers? -1 and 0, sure. If so, let's expand this way, since we're working now with integers. We'll say -1 and 0. You can't find something in the middle. Or you could use the same example. You can use again 3 and 4 because hey, 3 and 4 also belong to the integers. We just made it bigger, but we can still use 3 and 4. Exactly, Samer. If again z between 3 and 4, there's no integer between them. Good. So this also doesn't work. What about the quotients? So quotients like fractions. Can you find between any 2 integers a fraction? Sorry, between any 2 quotients, any 2 fractions, can you find another fraction? You guys made me make a poll. I hope you're happy. So what do you think for quotients? Would it work? Like if x is 3/4 and this is, I don't know, 2/1. So just 2. Would it work here? Can you find something in the middle between x and y? Okay, why did you answer no, Zahra? It's fine, Samar. It's okay. I have no idea. Let's see what we got. And I have no idea. I say yes, but they aren't letting you answer. Okay, it's fine. So I think most of you, yes, you said yes. And yeah, it makes sense, right? Like for example, 3 and 4 and 2. You can simply just say, hey, 3 plus 4 plus 2/1. You can find the common denominator like 3 plus 8/4. And then the whole thing, you can divide it by 2. So you get something like in the middle. So yeah, for quotients, it seems like it might work. Good. So sure. What about the real numbers? So R. would it seem like it would also work for the real numbers? Like if x is, let's say, radical 2 and y is 3.333333 forever. Can you also find something in the middle? Yeah, it works. Why not? Just x plus y over 2. So radical 2 plus 3.333333 forever, just divide it by 2 and you're gonna get something in the middle. So it works, hopefully. Does anybody get that? Does anybody have a problem with what we said so far? Okay, good. But can anybody tell me why it actually wouldn't work for any of them? So it's actually none of them work. They're all wrong. I'll assume no for that. Well, the reason it doesn't work for any of these ranges, yeah. So my question was, or let's say, let me clear this first. What we concluded was that it doesn't work for this, it doesn't work for this, but it works for this and it works for this. I'm actually telling you it doesn't work for any of them. None of these ranges will make this formula valid. None of them. Why? Because we misinterpreted the formula. We assumed that they're saying you have your x, you have your y, and you can find something in the middle. We're assuming that they're telling us between any two numbers you can find something in the middle. But that's not what they're saying, yeah? They're saying you can find a z greater than x and a z less than y. That's it. They didn't say that x has to be less than y. We assumed that. We assumed that x is strictly less than y. It's like another thing we added, but it's not included. So would it work for any x or any y? No, just simply always choose that y is less than x and it'll never work, right? Hey, x is, let's say, 5 and y is 1. Then it'll never work. For the naturals it won't, integers won't, and for the real numbers definitely not, because you can't find something z that's bigger than 5 and smaller than 1. You can't do that. Is it clear? Like, does the trick question kind of get you? Okay. So again, the whole point of this problem is trying to read the formulas like as thoroughly as possible. Don't assume stuff on your own. I'll read the formula one more time. For any x, for any y, you can find a z such that this x is less than z and this y, sorry, this x is less than z and this y is greater than z. That's all they said. They didn't say anything about x and y. So this and this. They didn't say anything about x and y. So if you simply choose that y is always less than x, then this will never work. So that's the trick question here. And this was a previous, by the way. This came in one of your exams, previous years. Okay. Last question for the proofs. After that, you're free to leave. I'm gonna be recording the revision exercises. I have like 6 or 7 revision exercises I'm gonna be doing, and I'll upload them. So you don't have to stay if you need to leave. Last question for the proofs. Usually I'd solve this when we reach something called counting or statistics in this course, but I thought it would be nice to use here. What is the minimum number of students required in a discrete mathematics class to be sure that at least 6 will receive the same grade? If there are 5 possible grades, A, B, C, D, and F. So you have A, B, C, D, and F, your possible grades. And they're saying to ensure that at least 6 will receive the same grade. So at least 6 people, for example, got an A, or at least 6 people got a C. How many students will you need in your class to achieve this? Well, let's say you have 10 students. 6 factorial? Not so much. 6 factorial is like 6 times 5 times 4 times 3. It's a lot. And so it's not this. And 6 is also not right. It might work for 6. Like, hey, if you have 6 students in your class, it's possible they all got an A, but it's also possible that 3 got an A and 3 got a B. No, it's not 6 factorial, nor 6. What's the least number of students you need to reach this? Well, every time, let's assume every time you get get students, you'll distribute them in the best way that fits you to avoid this conclusion. Like if you have 20 students, you distribute them 1, 1, 1, 1, 1, then 2, 2, 2. You'll keep doing that in order to avoid the conclusion. Because you don't want to think about the best scenario. You don't want to think, oh, I have 20 students and all of them got an A, so of course 6 of them got an A. You want to think about the worst case scenario, which is they got distributed equally. So the best thing you can do as a defense is 5, 5, 5, 5, and 5, right? That's the best way you could do. If you have a class and you have 5 students that got each grade, if you get one more student in your class, they have to get some grade, and then you're done. They're either going to get an A, so now you have 6 students that got an A, or B, or C, or whatever. So with your best defense, you have 25 students, right? 5, 5, 5, 5, 5, that's 25 students. That's all you can handle without reaching the conclusion. If you get one more, that's 26. That's it. That you can't handle that. So 26 is the least number of students to guarantee that at least 6 have gotten the same grade. Using 6 factorial, it will work. Like 6 factorial, it's a lot of students, so definitely 6 would have gotten the same grade, but it's not the least. It's not the minimum. Okay. Again, this is usually something we're gonna solve exercises like this later on. Yes, it is saying, the question is saying that 6 should have the same grade, but it's saying what is the minimum number of students. So 6 factorial is not the minimum number of students. 26 is. Yes, maybe if you have, yes, if you only have 6 students, it's possible that they got an A, But that's a specific case. I can give you a counter example if you have 6 students, 3 got an A and 3 got a B. So it doesn't work. This is a counter example. You have to give me a number of students such that no matter how I distribute it, 6 will get the same grade. And it has to be the minimum, which is 26. Okay? So these type of problems, we usually solve them later on, but I just wanted to give you an idea of what the pigeonhole principle means. Pigeonhole is, if the origin of it, it says if you have n+1 pigeons, and if you have n boxes or n cages, then at least one box is going to have 2 pigeons, right? N boxes and n+1 pigeons. So if you distribute your pigeons 1, 1, 1 on each box, eventually you're going to run out of boxes and you're going to have at least one box having 2 pigeons. You might have more. You might have a scenario where you put all your pigeons in just one box. But the principle says at least one box is going to have 2 pigeons. The question is a different taste of it. What's the minimum number of students required to get at least 6 grades? So different. It's like saying how many pigeons you'd need to ensure that at least 6 pigeons will be in one box. At least 6 students will get the same grade, and so on. Okay. So that's it for proofs. If you have any questions or anything that have to do with what we said, you can ask me now. Otherwise, you can either stay or because I'm going to be going over some revision questions. Again, try to solve this, yeah? My advice, resolve 1 and 2, then do 3 with the hint I gave you, then 4. This is an important question. And I'll upload this as soon as I can.